Imagine looking up at the night sky. You see countless stars. They seem fixed in place, part of a grand cosmic ballet. They move together in giant families we call galaxies. Our own sun is part of one such family, the Milky Way. It travels with its neighbors, following a predictable path around the galactic center. This is the normal life of a star. But what if a star were to break free from this dance? What if a star was cast out, flung from its home, destined to travel alone across the vast, empty void between galaxies? This isn't science fiction. It is a reality for some stars. We call them rogue stars or hypervelocity stars. They are the loneliest objects in the universe. They have been ejected from their birthplaces with incredible force. Now they journey through the darkness, unbound by the gravitational pull of their home galaxy. Their story is one of violence, speed, and solitude. These stars challenge our understanding of how galaxies work. How does a star become a rogue? It doesn't happen by choice. Think of it like a game of celestial pinball. A star gets too close to something with immense gravitational power. This could be another massive star, or even the supermassive black hole at the heart of most galaxies. The gravitational interaction acts like a slingshot. It accelerates the star to an incredible speed, flinging it away from its original path. When a binary star system strays too close to Sagittarius A, the black hole's immense gravity can capture one of the stars, pulling it into a tight orbit. In the process, the other star is ejected with tremendous force. This gravitational kick sends it flying out of the galaxy at speeds of millions of kilometers per hour. Another way a star can be set on this lonely path is through a supernova explosion. If the explosion is asymmetrical, it can give its companion star a powerful kick. The speeds of these rogue stars are truly mind-boggling. They are the fastest stars we have ever observed. To escape the Milky Way's gravity, a star needs to be traveling at more than 500 kilometers per second. That's over 1.8 million kilometers per hour. One of the first to be discovered was He 0437-5439. It is racing away from our galaxy at a staggering 723 kilometers per second. Another famous example is S5HVS1. This one is even faster. It was clocked moving at an incredible 1,755 kilometers per second. This speed is so extreme that astronomers are certain it was ejected by the supermassive black hole at the center of our galaxy, Sagittarius A. Each rogue star is a messenger, carrying with it a story of cosmic violence and incredible power. They remind us that the cosmos is a dynamic and sometimes violent place. At its heart, a rogue star is a cosmic exile. It is a star that no longer belongs to the galaxy where it was born. While most stars spend their entire lives orbiting peacefully within their galactic homes, a rogue star has been violently expelled. Instead, it embarks on a solitary journey through the near-perfect emptiness of intergalactic space, a vast and lonely ocean between the islands of galaxies. The stars in our constellations are our neighbors. A rogue star, however, is a transient visitor just passing through. Imagine a bustling city with millions of inhabitants. Now picture a single car speeding through at an impossible velocity, destined to leave the city limits forever. A rogue star faces a much lonelier fate. It will spend billions of years traveling alone, forever cut off from the stellar nurseries that gave it life. The main idea that rogue stars introduce is that galaxies are not closed systems. They show us that galaxies are leaky, capable of losing entire suns to the vast emptiness beyond. This process could have populated the intergalactic void with trillions of lone stars. It means that the space between galaxies is not entirely dark. Furthermore, rogue stars serve as unique messengers. They act as emissaries, carrying vital clues about the powerful events happening in the galactic core. By studying these cosmic runaways, we're learning about the very fabric of the cosmos, its hidden power, its chaotic nature, and the invisible threads of gravity. They're the untamed spirits of the cosmos, and honestly, their story is just beginning to be told. Once a rogue star is launched, its journey is one of profound and unending solitude. Its destination is, in a sense, nowhere in particular. For hundreds of thousands of years, it will ascend through the galactic halo, eventually fading into a single beautiful swirl of light in an otherwise black sky. After millions of years, it will travel through the intergalactic medium, a near-perfect vacuum. The nearest star might be thousands of light years away. The ultimate fate depends on its mass. A massive star might explode as a lonely supernova. Smaller stars could travel for billions of years before burning out. They will continue to drift silently through the void, cosmic ghosts on an eternal voyage, a forgotten spark in the infinite night between the galaxies. Finding a rogue star is one of the greatest detective challenges in modern astronomy. It is like searching for a single specific needle in a colossal cosmic haystack. The hunt begins with massive surveys of the sky. Astronomers use powerful telescopes to systematically map huge swathes of the heavens, capturing data on millions of stars at once. They use spectrographs to break down starlight into spectra. This spectrum is like a star's unique fingerprint, revealing its radial velocity, the speed at which it moves toward or away from us. The true breakthrough came with Gaia, a revolutionary space observatory. Its mission is to create the most precise three-dimensional map of the Milky Way ever attempted. Gaia measures stellar positions with micro-arc-second precision. This is equivalent to measuring the diameter of a human hair from 2,000 kilometers away. With this data, hunting for runaways has become a new kind of science. This is how S5HVS1, the fastest star known, was discovered, hiding in the Gaia data. Every rogue star we find is more than just a fast-moving object. It is a messenger carrying a story from a distant and violent past. The story of S5HVS1 is a perfect example. When astronomers traced its path, the trail led directly back to Sagittarius A. This discovery was a smoking gun, the clearest evidence yet that our galaxy's supermassive black hole is actively flinging stars into space. Another discovery is the hyper-runaways from the small Magellanic Cloud. Their paths all pointed back to the same origin, telling a story of gravitational billiards in a stellar nursery. Each rogue star is a piece of a larger puzzle. They are messengers from the most extreme environments in the universe, delivering first-hand accounts of events we can only imagine. We have journeyed across the cosmos, chasing the shadows of the wildest stars. These are not mere curiosities. They are fundamental to our understanding of the universe. They show us that galaxies are not static islands, but dynamic systems that are far more chaotic and interconnected than they appear. These stars are pioneers, carrying the chemical fingerprints of their birthplaces into the most desolate regions of space, seeding the void with the products of stellar evolution. Our exploration of rogue stars is far from over. We are just at the beginning of this incredible story. Many great mysteries remain. How many more are out there? Is there a vast, unseen population of smaller, slower rogue stars drifting silently through the halo? The rogue stars are the most dramatic actors in this cosmic play. Their story is unfinished, a thrilling cosmic mystery waiting for the next generation of explorers to uncover its secrets.